So in this next series of lectures, we will be discussing measuring the occurrence of disease and various measures commonly used in epidemiology. First, I just want to point out the difference between an absolute measure and a relative measure. An absolute measure is one that's measuring a factor simply using the factor itself, such as one's age or blood pressure. In contrast, a relative measure is a measure relative to some other dimension or factor. So an example may be one's number of cells per microliter measured, number of persons in a room. In epidemiology, most population level measures, which is what we're measuring, are expressed as relative measures because absolute measures are generally uninformative because they do not provide us with any sort of unit of measure that's relative. Now, the three key categories for epidemiological measures are measures of frequency or the extent. So we're going to discuss these, but measures such as crude or adjusted measures of death, that would be considered a measure of frequency. A number of cases would be a measure of frequency. The next category is the measure of association. So this is when we're interested in looking at associations between one group to that of another. For example, relative risk. And then the third type is measures of impact. This could be the measures of the effect of, say, a number of deaths in a region per year and its effect on the economy. We're not typically focused on measures of impact in this class, but suffice it to say that is a category that epidemiologists do calculate depending on the research question. Now, I want to briefly walk through the difference between proportions, rates, and ratios. A proportion is a measure of x over y where x is contained in y. So for example, the number of males among the total number of people. That is a proportion because those total number of people include those males that are in the numerator. Now a rate is a type of frequency measure where x, representing the numerator, involves some sort of nominal level data representing the presence or absence of some health-related state or event. And oftentimes rates are expressed as a unit of time. And all the persons or values in the denominator of a rate have the potential as well to be in the numerator as they do with a proportion. So really the key difference between a rate and a proportion is that rates, as I said, are often represented as a function of time. Person time, for example, is a common rate unit of measure. And then thirdly are ratios. And the difference here is that x over y, where x is not contained within the y. And so the ratio is providing a relative magnitude of two quantities that are both separate and distinct. So an example may be the number of male deaths over the number of female deaths, or the number of males with a disease over the number of females with a disease. So some example of ratios. I just noted the first one. So the second is a little trickier. You could ask, or you could say that in a given year there were, say, 21,025 new cases of tuberculosis. And during the same year, there were 895 deaths attributed to tuberculosis. And so you can calculate the death to case ratio. And you can then calculate the number of deaths per cases. Now, why this measure is not a proportion is because those who died in the year that the data are being calculated may have, or most likely, contracted the TB in a prior year and thus are not all part of the denominator. So these are the common measures in epidemiology that we're going to discuss now. But before doing that, it's important to discuss the different kinds of population that data could be coming from. The first would be a fixed population. This is a population where the size of the population doesn't change except for the case of attrition or death. So you have no new individuals coming into your population. It's a fixed population. That's in contrast to a dynamic or open population, which has migration of individuals coming in and out of the population due to births and deaths, as well as just simple movement. And then a stable population is when the size and the distribution by certain characteristics such as age do not change. This is generally the most simple type of population, and it's one that we tend to use in when discussing basic epidemiological concepts. So we really in this class are not going to differentiate between a fixed and a dynamic population. We're generally assuming that our population is stable, unless otherwise stated. Okay, so the first term or measure, I should say, that I would like to discuss is the point prevalence. So point prevalence is the number of existing cases of a disease in a population divided by the number of persons in that population at a specific point in time. And this is usually expressed as a proportion or a percentage. Now, what's important to keep in mind here is with prevalence, prevalence represents, again, the number of existing cases divided by all persons in the population. Later, when we talk about incidence, you'll notice the difference there because incidence represents only new cases. The next is period prevalence. Is similar to point prevalence, except that in now this measure is as a function of a period of time rather than a specific point in time. So, for example, we may be interested in the prevalence of heart disease in the United States in 2017. That would be calculated as the number of existing living persons with heart disease divided by the number of living persons in the United States in that 1 year time period. So now I want to discuss incidence proportion. And as I said a moment ago, incidence is the measure of new cases of disease over the number of persons at risk of developing the disease. So again, the key difference here between prevalence and incidence is new cases over at risk, and prevalence is all cases over total population. And an incidence proportion is represented as an incidence per person over during a specified period of time. So the next concept is cumulative incidence. This again is a measure of incidence such that the denominator includes only those persons at risk of acquiring the particular disease or outcome that we're measuring. Cumulative incidence is synonymous with attack rate, risk, probability of disease, as well as incidence. So all of those terms are synonymous. Cumulative incidence usually is expressed as a percentage. For example, we can say 2% of the 500,000 persons living in city A developed diabetes in 5 years. And as I noted, this measure must include the length of time. So in the statement, for example, 5-year cumulative incidence. Without that measure of time, the unit of measure the measure is useless. We can take incidence and calculate it in terms of lifetime risk. This represents the number of new cases of disease in a specific time period over the number of persons at risk in the population. So for example, we could say that 20% of persons in our particular study that we had developed diabetes in their lifetime. Okay, I want to talk now about attack rates. Attack rates represent the number of people who are exposed to something who acquire the outcome. So incidence, in a sense, is a primary attack rate, as was noted before. You can now have secondary attack rates, and this represents basically the number of secondary cases due to those from the primary cases. And so this is typically represented as a percentage. Again, it's in a specific time period. And here it's the number of new cases of a disease in a time period over the number of people who began in that time period minus those who became a primary case in that time period. So I want to talk about incidence rate or incidence density. Those are synonymous terms. And it's an incidence measure, but now instead of the denominator being persons at risk, in this measure, the denominator is person time at risk. This is useful to calculate when the length of at-risk time is unequal among all the persons in your study population. So with incidence rate, the unit of time must be presented, as with incidence density, as with cumulative incidence, and that essentially incidence rate is viewed as the instantaneous rate of disease occurrence at a particular moment in time, and that is because it's calculating person time. So we often calculate incidence rate over one or more periods. And one could interpret the incidence rate as how rapidly is the disease occurring in a population relative to the population size. Now, the way we calculate person time is shown here with a simple example. Imagine you have 10 people followed for 3 years. So that essentially calculates out to 30 person years or 360 person months. But you could also have 3 people followed for 10 years, giving you the same length of person time. And then this is an example of how we sometimes look at person time in a graphical fashion. And here we're looking at 8 subjects, where the red solid line represents someone who was followed and acquired the disease, and the green line bar represents those who were followed and did not acquire the disease. So to calculate the incidence proportion, which is again just a number of persons who acquire the outcome or the disease over the total number of persons at risk. So in this instance, it's going to be 62.5 over 100 in 3 years, or 5/8. However, if we want to calculate incidence density, we're now dealing with person time, and now we'll have 5 over 18 person years, calculating out to be 27.8 per 100 person years. So those two measures are clearly different numerically, and it's because one is a function of persons and the other is a function of person time. And just to note, this value here of 62.5 divided by 100 is what happens after we essentially standardized the 5/8. And this is a common approach so that the denominator is per usually 100 or 1,000 units of measure. And to calculate the 1-year prevalence and the 2-year prevalence, we can again calculate the number of persons with the disease at 1 year, which is 5, divided by the number of people in the population at 1 year is 8. So the 1-year prevalence is 5/8. However, the 2-year prevalence is going to be 3/6 because at 2 years there's a loss of 2 people from our population. So our denominator shrinks down to 6 and our numerator decreases from 5 to 3. So our 2-year prevalence is 50 per 100. So some considerations when calculating person time. It's important to account for subjects who become lost to follow-up. We usually do what's called censoring them at the time they are lost to follow-up, but we still include their person time in the denominator, but they're not counted as a case in the numerator. There are also times where you have a recurrent case scenario, so you're dealing with a disease that's recurrent, and in that instance you're going to account for multiple events oftentimes for the same individual, and that's okay. And then in some situations you have to account for recovery time if there is the case of the recurrent illness situation. So the time during which someone is ill from the disease we're studying has to be accounted for when calculating their total person time at risk. And we'll go through some examples of this